Hello everyone, my name is James Strachan. It's great to be here at Jenkins World. This is my first Jenkins World. It's lovely to be here. About a decade ago I wrote a programming language called Ruby. So it's kind of nice to be here for my first Jenkins World when Jenkins 2's out and Jenkins Pipelines are out. So now Jenkins is really moving these days, so it's kind of nice to be here. So I hope you're having a great time at Jenkins World. It's a great conference. It's nice to see so many of you here. There's two talks at the same time, this one and Carlos's talk, both with Kubernetes in there. So it's nice to see so many people in my talk. So thank you for coming. I'm sure Carlos has lots of people as well. I'm going to talk about lots of different things today. I've got one of the longest titles, How to Do Continuous Delivery with Jenkins Pipeline, Docker and Kubernetes. I think I've won Open Source Project Bingo for that title. So for those of you who saw Sasha's keynote, he mentioned this as well. Software is eating the world. Right? Almost every business is a software business now. We often say the phrase, especially near Silicon Valley, we often say businesses are being Uberized. That software used to be like a cost center and a way of saving costs. Now people see software as a way of creating new business value and competitive advantage. So Uber and Airbnb and Amazon kind of displaced the more traditional ways of selling books, doing hotels, doing travel. Pretty much every industry now is rife for disruption from companies that can just do software well, right? This is one of my favorite quotes. It is not necessary to change. Survival is not mandatory. Which is a bit mean, but in other words, everything's changing now. The last couple of years, how we even develop software has radically changed. Now high-performing software teams can go crazy fast, right? There's still teams out there that are very kind of legacy, monolithic, they release every year or two, and don't go very quick, but high-performing teams can now go crazy fast. So it's imperative that all of us figure out how to develop software fast. Now, software is crazy hard. It's really, really hard. Most software projects fail. And they fail because we spend all this time writing software that's the wrong software. Writing software is easy, right? There's millions of programmers in the world that can write code. Writing code is easy. Writing code that works and delivers real business value is really, really hard because often we build the wrong thing. We spend often 90% of our time building all these features that customers don't need or want or care about. And all of those 90% of features then means you have all this ton of crap to maintain and refactor and support and test when it adds zero to your bottom line. In fact, that 9% of software is usually of negative cost because you have the lost opportunity cost of not building the right thing that your competitors have done, right? So it's incredibly important for us to develop the right software that really delivers business value. Now the tricky bit is, customers don't know what they want, right? Do you remember the iPhone? Customers said, we want a hardware keyboard, we want a stylus, we want a pluggable storage thing that I can put memory cards in the side, we want a flip-out thingy. All the stuff customers said they wanted as a phone was wrong, and what we really wanted was an iPhone, right? Increasingly, Henry Ford is another one. Customers said they wanted a faster horse. They wanted a freaking car, right? So customers are not really good at asking for what they want, but customers are really good at saying what they don't want, right? You try and guess what they want, you give them something, and they kind of go, oh, that didn't really mean that, I meant this. So the only real way of doing software and to hit any real significant business value is to go really, really fast, keep iterating, and see what works, right? It's pretty much impossible to talk to users to find out what they want and build it, and for that actually to be useful. All you can really do is guess, do experiments, try things out, and then see what actually happens, get feedback. So what we all really need to do is create value through speed, iteration, and continuous improvement. The way to make really good software is not, the first version is always terrible, right? It's version 50, version 2000, that's the good one, right? You do it again and again and again, and iterate and iterate and iterate, and get feedback and get feedback. One of the reasons open source has been so successful is we get real feedback from real people really using the product. And those people that are really using the open source talk directly with human language to the people who wrote the code, right? In business, often you have, say, a sales guy talks to somebody who's the manager of the person who uses the widget, and you get Chinese whispers coming up and down, and by the time the developer finds out, it bears no relation to what the thing was, right? It's back to the hardware keyboard and the memory stick and the stylus and the yada yada yada, right? So The only real way of doing software is continuous, fast, go fast and get feedback. So we'll kind of want this kind of thing, continuous assessment. We want feedback loops. We want to go as quick as we can and just keep going round and round and round as quickly as possible. So that sounds cool. So how do we do such a thing? Well, here's the answer. Now, you've probably heard this a few times this week. Continuous delivery through containerized microservices. This is Jenkins world. You've heard all about continuous delivery. We kind of get that bit. Say microservices one more time. So a lot of people say microservices. This is okay. I'm going to say it one more. I'm going to say it 2 more times. Okay. So I'm going to say it 1 more time. So microservices to me is just about going fast. That's all it's about. It's not about lines of code. It's not about technologies. It's about going fast. So do you remember the Mythical Man month? This is like a 20 years old book. You have a large team, it's going too slowly, and you want to go faster, so you add more people to the team, and the team goes slower, because more people makes more contention, it takes more time to have meetings, and to make decisions, and then people have wildly different things, and it takes a lot more time to get agreement. So the 2 things of microservices that makes it work. The first one is you take this big monolith of code, and you split it into lots of pieces. But the key thing is those pieces have to be developed and released independently. So this is the bit people often miss. I think every system I've ever seen in my many decades, I'm honestly really old, many decades of working in IT, every complex system, when we build it, we've been doing this for 30 years, you write a massive diagram on the wall and you draw lots of boxes and you name all the boxes. Everybody decomposes every system into components, right? We've always done this. The difference is we normally release the whole thing as one honking monolith with one massive team. And what we often do is we silo the teams. So one team do testing, one do design, one do specifications, one do operations. The 2 things that microservices changes is it's not one release anymore, it's lots and lots of independent releases of things, right? Which means you don't need coordination. You split your one big team into 50 teams and each team releases every hour, right? There's no coordination required, you just release quickly. So the first point is splitting the software into pieces that are released independently. The second part is organizational. Rather than having one massive team which is siloed by function, testing, development, design, UX, operations, you have one team, 2-pizza team, a smallish team like 6 to 8 people, and they look after the entire life cycle of the software, from design to production to maintenance to upgrades, the entire life cycle. Now, I'm a developer, I mostly write code. As soon as you're on support for your code, you tend to write code a little bit differently, right? Open source code has often been slightly better quality than a lot of the in-house proprietary software I've seen before, because people can see it and it's on the internet, right? So just the fact that your code is on the internet, you tend to go that extra slight, people other than me try and go that extra mile to make the software a bit more polished and better, right? My software is often a bit crappy, but most people have more of a sense of respect to themselves, so they tidy up their code and make it look nice, right? There's the same kind of thing. If your code is going to be in production and you have to manage it, so if it fails, and you get a call in the middle of the night, you have to fix your code, you tend to develop your software thinking about production and operations as you write it. So you don't go to town writing every kind of whizzy feature you can think of. You make your stuff simple so it works and it can be restarted, right? You design and develop your software so it's designed for production, right? Rather than focusing on whizzy bang features. So these 2 things of microservices, splitting the software up into lots of independent releases and splitting the teams into a lot of independent teams, those 2 things make you go fast. Now, microservices are complicated. Right? You're adding huge amounts of complexity because you've got lots of independent moving parts. It's a bit like the internet. You have lots of ISPs, there's lots of caching and DNS and yada yada yada. Microservices makes things complicated, but it allows you to go faster, which is the key thing. Okay, so that's microservices. I'm not going to mention it anymore. Oh, okay, maybe a couple of times. So we've got Jenkins Pipeline, which is awesome. Jenkins is amazing. Jenkins Pipeline, I love it to pieces. I have a Jenkins server. It's got pipeline inside. Is that enough, to do microservices? Well, nearly. I mean, to be fair, Jenkins does almost everything you need, but there's a few more pieces. So the problem comes, as you start to adopt microservices, you have lots of independent teams, and each one of those independent teams wants to be able to do things by themselves without having to rely on other people or get agreement. So you want, each team probably wants their own Jenkins master, because one team wants to go with Blue Ocean because it looks awesome and it looks like it's way faster. So other teams might prefer what they know, Jenkins 1 even. So you want to allow different teams to go at different speeds, to use different versions of Jenkins, different Jenkins pipelines. Also, if I'm on a team, I don't want to see any other team's builds. I don't really care what the teams are doing. All I care about is my builds and my team. So I want my own server that I can do whatever I want inside. I don't want to have to wait for some ops guy to install some version of Maven for me. I want to pick whatever version of Maven, whatever version of Node, whatever version of anything I want to use. I just want to use it and get on. So from a speed perspective, we kind of want to decentralize Jenkins, so every team gets its own Jenkins. We also have the whole environment thing. So if every team is going to be doing development, system testing, load testing, sub testing, staging, possibly user acceptance testing, regression testing, and production, and one team is doing all of it, you kind of don't want to be raising tickets per microservice to say, please can I have a couple more VMs because I've got another test to do. You kind of want your own cloud of sorts, where you can just run stuff and use whatever compute resources you need, whether it's disk, network, or compute. So we kind of want like a platform that we can all do microservices on top and run our Jenkins inside, and so that we can then use Jenkins pipelines to deploy software and test software and run it in testing, staging, and production, right? Because we're all trying to go fast, we also want to stop all this stuff of running things on different machines and different operating systems. Unit tests, that's fair enough. Unit tests is like JUnit or something, and that's all cool. Everything outside of unit tests should be running on as close to production as possible, because you're just wasting your time testing on different things, right? You should always test your software on the same operating system, the same version of Docker, the same version of Kubernetes, the same version of everything. You should be testing production images all the time. It doesn't make any sense to have a different version of Linux that you do your system testing on, and then you deploy to production, which is totally different, right? You always want the same environment all the way through your development pipeline. Finally, we need to automate things. Now, microservices are a bit like crack. You do a couple of them and it seems fine, it seems really nice. And then before you know it, you look around and you've got 200 microservices, and then it's 1,000, and then they grow like wildfire. So we need to automate, right? We don't want to be handcrafting 1,000 different Jenkins pipelines just to get stuff done, because we want to go quick. So what we kind of want is a microservices platform, which is easy for teams to self-service, so they can develop and test and release software really quickly with a couple of clicks. They can just make a new microservice and go to production almost immediately, and we need it self-servicing fast. What we kind of want to be doing is every time a team wants to make a microservice, you should go to production immediately and get something in production, even though it doesn't really do anything, and then get in the habit of iterating, right? Every time you make a code change, you want to get in the habit of doing rolling upgrades to your testing environment and your production environment. You don't want to do rolling upgrades in production. You want to have tested in staging, right? You want to test rolling upgrades and version changes. One of the things about DevOps is if something's hard or painful, you should do it more often, right? The more you do painful things, the better you get at doing it. So we should be doing releases and rolling upgrades as much as we can, because then we get better at doing rolling upgrades. Okay, so that's what the microservice platform is. I'd like to introduce you to a small open source project, which is a massive open source project. It's Apache licensed, which is built it stands on the shoulders of many giants. It's basically a microservices platform that helps you use Jenkins Pipeline and Docker containers and do all of these features. So it helps you spin up new microservices, it helps you build them into immutable Docker container images. The reason everybody's so crazy about Docker container images is from this one binary container image, I can spin that container up anywhere within seconds. It will run on any public cloud, it will run on any PaaS, it will run on any infrastructure, it will run on Kubernetes, it will run on Mesos, it will run on the Docker Swarm Kit. Forget those other two, you should just use Kubernetes, but just for completeness, you could use Mesos and you could use Docker Swarm Kit, but please use Kubernetes, but I'll talk about that later. There's also a bunch of other stuff. So we can do rolling upgrades between environments. So every time we do a code change, whether it's testing, whether it's staging, whether it's production, or user acceptance test, we can do automatic rolling upgrades, which means we can release a new feature, and while the system's live, people are using the system, we can roll out a new version of the feature. Once the containers are running and they're ready and they're warm and they've warmed their cache or whatever and they're totally ready, the load balancer will then start passing requests over to the new version. Once the new version looks to be working, you can then dial down the old version. So you can gradually move the new version in and slow the old version away. If for whatever reason anything goes bad, you can just flip back again. So we can get into the habit of not stopping and starting or bridging up a whole cluster twice and doing the blue-green thing. We can just dynamically, gradually do rolling upgrades. And you can do all kinds of fancy things like A/B testing and whatnot to do clever advances. Once you start using microservices and you have lots of them, you often have lots of containers and they're often on random machines. The whole idea of searching into a well-known server and looking at a file in a well-known folder kind of goes away. So you need a way of centralizing logs and metrics. Otherwise you have no idea what's going on. So you need to centralize your logs and metrics because you need feedback. Feedback to find out if things are going too slow, if things are going too fast, if you're getting too many exceptions. You need to be getting all of that data and analysing it all the time to see, is your software getting better or worse? Are you getting more and more exceptions? Is your REST API serving too many 404s? Are you getting all sorts of stack traces in your log4j app and so forth? So you need lots and lots of metrics and tools. And finally, we need feedback, because we need feedback loops to see, are our builds getting slower? Are users clicking on all the things they should be? Does the new version have better or worse click-through conversion rate? Or do the number of orders go up or down with a new feature? We need to be putting all the metrics in so we can track this. We should be focusing on our core business objectives. And every time we make a change, we see, is it better, is it worse? If it's worse, revert and try a different thing, right? And do experiment-driven development. Okay, I'm going to quickly whiz through and do a demo, and then I'll talk a bit about all of the implications internally, how it all kind of works, how we use Jenkins, how we use Docker and stuff. So the three big giants that Fabricate stands on the top of, there's many things it stands on, but the big three are Jenkins Pipelines, which you guys know about this already, I didn't talk about that too much. The middle one is Docker. Docker started 2.5 years ago, something like that, and it's kind of changed everything. Linux containers have been around for about a decade. Google's been using Linux containers for a decade in production. It runs something like Google Day or something like that. Pretty much everything Google runs, you know, Gmail, Google Search, all of the different Google things, are all running containers. It even runs VMs in containers, which is kind of wacky. So Google's been doing that for years. What the Docker guys have done is figured out a nice simple way of making it easy for developers to make and consume Docker images. So packaging up software into a box that's then easy to transport around and run. So anybody who's ever tried to install, I don't know, some Ruby for the first time, or NPM for the first time, or Python for the first time, you have all these different package managers and it's a nightmare. What you can do with Docker is somebody who knows what they're doing can make a Docker file that installs the software and you just run the container. You don't have to worry about installers or NPM or all that kind of stuff. So Docker is the perfect way of packaging up software into immutable images you can just run anywhere. Now the third one of these icons is something called Kubernetes from Google. Google knows what they're doing with containers. They've been doing it for a decade, they're the market leaders, they've invented all this stuff. Google has a habit of writing these papers that describes its technologies. So it did MapReduce paper, and then Yahoo then copied it, implemented it, and then Hadoop was born. And then Bigtable came along, and then that became HDFS. And then Chubby came out, which became Zookeeper. And so there's been this history of Google coming out with a paper, and then someone writes it in Java and gives it to Apache. I think Google eventually just got fed up saying, well, damn it, we're going to write this one this time. So I think they did Kubernetes saying, the Vault paper's just come out, which is how they do container scheduling. This time Google said, no, we're going to do an open source project, and we're actually going to write it this time. So Google made Kubernetes to start with. And it's a library for orchestrating containers, which sounds a bit of a mouthful. Basically, it's a way of turning a bunch of boxes into a logical cloud that you can then just run Docker containers on, and it keeps them running. So you say run 3 Tomcats and run 4 Jenkins servers. And it will make sure that if any of the boxes fail, it will move those containers onto other boxes. If any of the containers fails, it will restart the containers. So it keeps all the software you need running. If you start using microservices and you've got 1,000 microservices in production, you kind of don't want to be like logging into all these boxes and doing a PS and just checking what's running, right? You want an automated system that just does this stuff, right? So that's what Kubernetes is about. It basically keeps stuff running, it can auto-scale things, and you can do load balancing between containers. It's awesome. I could talk for days about Kubernetes, but I'm going to try and stop. One of the things about Fabricate is it's built on the shoulders of all of these open source projects like Kubernetes and Docker and Jenkins, but it's also microservices all the way down. Everything's a microservice, and you can opt in and out of various different pieces of Fabricate, which we'll see in a minute. So I think it's demo time. Let me quickly do a demo. Once we do the demo, let me get that full screen up. Yeah, okay, here we go. This demo is actually going to be using Google Compute Engine, but don't worry about that. You can install Fabricate on any Kubernetes cluster. It works on Amazon, it works on Azure, it works on Google, it works on premise, it works on OpenShift from Red Hat. This demo is going to be spinning up a cloud, so we're going to start with nothing at all, nothing installed on the machine, nothing. We're going to use the website of Google, going to the Google Cloud Platform, we're going to create a new Google container engine, which is basically a cluster of Kubernetes hosted by Google. So we're going to type in, you probably can't read this at the back, we're going to pick which region, we're going to pick how many CPUs per node, I'm going to pick how many nodes, which I think is 3. So you just type in this web form, hit create, and providing you've registered your credit card, it will spin you up a Kubernetes cluster, right? So it's a few clicks. Don't worry about the next kind of 20 seconds of the demo. So any minute now, the cluster spins up, and then you've got your own cluster, so that was nice and easy. The next little bit of the demo is going to show how the command line is going to be able to connect to the cluster. So we're going to use our command line shell on our laptops to connect to this cluster on Google that we've just created. So there's a little bit of shell magic just about to appear, where we're going to copy the login and password to get into that cluster. And we're going to open the shell in a second and copy and paste the username and password into this little bash script. There you go, that's a little bash script. Don't worry about the details. We have a much easier way of doing this now, but don't worry about that. We're going to copy and paste a few environment variables for the login and password so we can log in. Now we're going to use the command line and log in to this cluster and list how many nodes are in the cluster. So this is going to be fairly quick. We're going to copy and paste all that stuff, find the shell, so we've copied, we've got a shell here, we're going to paste it. You won't be able to read this, but don't worry. And now we do kubectl get nodes. Let's pause this a sec. Kubernetes comes with a command line shell, which is kubectl, but people say kubectl, which is cube. It gives you a cuddle, you feel nice. So whenever you say kubectl, you just smile and you feel better with the world. So kubectl is the command line shell that lets you list nodes, list containers, create containers, look at the logs in the container, and all that kind of stuff. So we can see we've got 3 nodes in the cluster, so we can see how a laptop can now talk to Kubernetes and do various different things. Now we're going to install Fabricate. Now everything you're seeing up to here is something like an Opsy person would do for you once, for your organization. So we download this binary called Go Fabricate. There's a slide coming with all the links to all this kind of stuff. We download this Go Fabricate binary, we type Go Fabricate deploy, we get some nice ASCII out there, which is cool. And then that's going to install a bunch of containers in Kubernetes. And once we hit, there's the cluster it's installing, you really can't read that, that's the URL of where it is. And we type yes, and it's going to install a bunch of Kubernetes stuff. Now what that's doing under the covers is that's deploying a Jenkins, it's deploying a Nexus, it's deploying a Git server called Gogs, and a console and a wizard called JBoss4 that lets you spin up new projects using Maven archetypes and templates and various other bits and bobs. We'll see this in action in a second, but everything you've seen up to now is something an Opsy person would do once, and then you're done, right? But I thought I'd show you from naught to finish, I'd show you the whole thing. So now we should have a bunch of pods starting up. If you do kubectl get pods, we can see there's a bunch of pods that started. Pods is the Kubernetes term for a container. So we've got a bunch of stuff starting up, and within 20 seconds or so, we should get a console appearing. Now, it starts up fairly quick on Google. If you were doing this on your laptop, it might take a little while for these Docker images to download, right? There's maybe a gig or 2 to download. So over the hotel Wi-Fi, I'd give it an hour, right? It might take a little while. So the console's now started up. So now this is the Fabricate developer console, right? So this is the console that each team building microservices would use. Each team gets its own dashboard where a team creates applications. Now we're just looking at the developer environment right now. The developer environment is where you run your developer tools. So your Nexus, your Jenkins, your Gerrit, your SonarQube, your Artifactory possibly, whatever development tools you wish to use. Out of the box it comes with Gogs for Git hosting, Nexus for artifacts, a Docker registry and Jenkins. So out of the box it's got all the stuff you need to create microservices and deploy them and release them. Notice we can look at all the different containers that are running, and we can open a shell we can list the logs of any of the containers. So if like Nexus is behaving weird, we can just look at the Nexus log or Jenkins or whatever. We can also open a shell in any of these containers, which is kind of cool. So if something's going a bit wrong with your Jenkins master, you can sort of quick noodle in the command line shell and see what's going on. We also have a little app catalog where you can run other microservices. I think this demo we're going to run something called a management app. The out-of-the-box Jenkins platform is like the minimal set. So it's Jenkins and Nexus mostly, and a Git server. What you really want to do is do centralized metrics and logging. Notice, by the way, the drop-down menu. Once you start using various different tools like Nexus and Jenkins and Artifactory and SonarQube and Gerrit, you end up with all these different web apps that you often need to flick between. So you have this little drop-down menu that lets you quickly flip into the Jenkins console, flip into the Gogs console, flip into Nexus if you need to switch. But most of the time, we've tried to put all the developer operations inside this one console. The run button gives you all the default applications inside Fabricate. So there's Chaos Monkey for killing pods, there's GitLab, there's Histrix dashboard, there's Manage IQ for managing your hardware, there's a management app which we're going to run here. Now, everything you've seen on there, this is all completely open source, this is all best of breed open source projects. All we've really done is glued them all together on top of Kubernetes, so they all just kind of work. I was saying to somebody today, I probably wasted several months of my life just getting Nexus to talk to Jenkins. Like, just those two things, right? Every now and again, we end up with a new Jenkins server somewhere, and somebody else has configured it slightly differently, and you've wasted hours and hours and hours to get the two things to talk to each other. We've got GOGS, the Git server, talking to Jenkins, talking to Nexus, so that every build builds through Nexus, uses Nexus as a proxy to download from the internet, so you have an on-cloud cache of all the Maven artifacts, and releases going to that Nexus. And it passes secrets and all that kind of crap, and we can do promotions using secrets and stuff. In this case, what we're doing is we're running the management and the logging and the metrics apps. So metrics, as in numeric values like CPU count and disk usage and all that kind of stuff. We use something called Prometheus, which is really, really awesome. Prometheus will capture all the metrics from every running container in the cluster. So whether that's Kubernetes itself, whether that's Jenkins, Nexus, or your apps, all of the metrics are captured. Any Java app, all the JMX metrics get captured. So all of those NB attributes get captured and they're stored historically. And you can then do alerts and charting and trend analysis and whatnot. The other thing we've installed is Elasticsearch as a backend for logs and events, and Kibana as a front end for looking at dashboards. So this is the Grafana front end, which shows various dashboards for looking at the metrics. So here we're going to look at the overall cluster health, like how much memory is being used, what's the CPU usage, how much spare capacity we've got, whatever. As we'll see in a bit later, we can dive in and look at the relative CPU count of different applications and so forth. Once you start running lots of microservices and lots of instances of each of those microservices, you absolutely need logging and metrics. Otherwise, you're flying blind. You've got no clue what's going on. So we've ran logging and metrics. So just to recap, we've started from scratch. We've pooped up a Kubernetes cluster on Google Cloud, and we can do it on Amazon, we can do it on premise, it doesn't really matter. It will run on your laptop, totally fine too. Then we've done one command line to run Fabricate on there. We've now got Jenkins and Nexus and GOGS running. We've got, with one more app we've run, we've got centralized logging and centralized metrics. We're now just showing the centralized logging, where we're going to show the logs that we generate already centrally across all of the containers that are running right now. So we've got logging, we've got metrics, we've got builds, and we've got GOGS, and Nexus. So that's what your ops guy should have done for you. So you should come in and say, hey, I want to make a microservice. You should have all this stuff running, right? Then each team goes into their dashboard, and this is where the developer starts. They click the Create Application button. Now, once you click the Create Application button, just before it goes any quicker, you've got the option of creating a brand new application from scratch or importing something that you've got in Git already, right? Pick whichever one you want. In this case, we're making brand new stuff. We have wizards in there for Spring, Spring Boot, Wildfly Swarm, Vertex, Apache Camel in this case, Swift, Node.js, .NET, Python, Ruby, blah, 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 blah. This whole thing is extensible, so over time you can make your own templates and sample projects, so you can have pre-canned microservices that do things the way you want to do them. Now the next screen you get faced with is you need to pick a pipeline. So we have libraries of pipelines that you just choose. Now we love pipelines, we think they're awesome, but what we found with microservices is, if you're doing a Spring Boot application, every Spring Boot application can be built in the same pipeline, really. Maven does all the building. There is no real difference on a per microservice basis. Or if there is a difference, that difference lives in the Maven pond. Or if you're doing two Node.js apps, the difference is in the gulp or the grunt file, not in the pipeline. So pipelines we've found are often very similar for the same technology. So we have a whole raft of libraries, a library of pipelines for different technologies. So rather than having to write your own pipeline, you can just pick one. Now you don't have to do this, you can just write your own pipeline if you wish, but it gives you a nice quick way. You just pick a pipeline and click go. Now it's going to take that Jenkins file. Well, firstly it's going to take the sample project, create the source code, create the Git repository, push the source code into the Git repository, create the Jenkins file in the Git repository. It's then going to create a Jenkins job for that Jenkins file that's in Git. It's then going to create a webhook in Git, so that whenever you push to it, it's going to trigger Jenkins to do a release. And now the release build is kicked off. This is the app dashboard that shows you all the environments for your microservice and the current active pipelines. You can see the build logs just starting. Now bear in mind, this entire cluster is 20 minutes old, so we've never done a Java build before, so we're about to download the internet right now. And we've got a brand new Nexus with nothing in it, so every time we ask for any jar, it's going to be downloaded into Nexus, and then our build container is going to grab it from Nexus and get it locally. So the first build is going to take a couple of minutes, but once that first build is done, your Nexus is now warmed with all of your dependencies, and the next build after that is pretty quick. While this build's chugging away, so we can see over time the build pipeline, the logs, and the environments and stuff. We'll come back to this bit later. While this is running on, let's create another microservice. So this is the list of all the apps we've got right now. These are the environments, by the way. We found that each team typically wants its own environment. So if you talk to developers and you say, how many environments do you have? And they might say, oh, 4. I have development, testing, staging, and QA, and production. Oh, that's fine. They have a certain number. And people give them different names. So we let each team define their own environments and define their own names of environments. And then you can use those environments in your pipeline to do releases and deployments and running upgrades. We'll come back to the environments in a second. Now we're going to create a Node.js app just to show we're totally polyglot and we don't really care what the language is for the microservice and how you build it. We're going to make a Node.js app. Again, we get a list of pipelines to choose from. Slightly smaller list because we don't have that many pipelines in Node.js yet, but we're going to pick a Node.js pipeline. This pipeline knows how to build a Node.js app, and again, it uses the environments from the team. So the environments aren't hard-coded, the environments are logical environments based on the team. So two teams could have different QA and testing environments, but the pipeline can be used for both of them, right? Using kind of like a logical environment name to map to physical environments. So the build's chewing along for the Node.js app. I'll just mention environments briefly. Environments are implemented in Kubernetes using something called namespaces. So what Kubernetes allows you to do is take one physical cluster of compute nodes that can run containers, and you can logically slice it into different namespaces. And any app in one of the namespaces, I'll just pause that a second. Did you see that very quickly? We're browsing the source code for the app right now. This console, we're trying to do a centralized console that lets you see every aspect of the software lifecycle. From creating the project, to looking at the pipelines, to looking at deployments, to testing, to browsing the source code, and if you want, editing the source code. Now, so here we're browsing the source code for the app we've just created, and we're just looking at the Jenkins file there. We don't really expect you to use this as an alternative to an IDE, but it's really kind of handy for doing demos and browsing around and doing a few changes. This is the Spring Boot-based application, so it's just a regular piece of Java with Spring Boot in here. This app actually happens to be a Camel app, which we also have a bunch of extra plugins for different frameworks. So if you've got a Camel app, we can visualize the Camel integration flows. This demo has a slide book. There should be icons there, and they're not there. So pretend there's amazing icons in the logo. So we're visualizing the Camel flow that's inside this application by analyzing the source code. So just back to the environment thing. What you kind of want is lots of logical environments. So you want production and testing, QA and whatever. If your microservice is running in production, it should connect to the production database. If your application is running in testing, it should connect to the testing database. And that's what namespaces do in Kubernetes. A single namespace, you only see other microservices and services in that namespace. So you don't accidentally, in a test, connect to the production database. So it's a nice way of writing a single application, deploying it to any namespace, and based on the namespace you're in, you automatically connect to that namespace's resources. So you don't have to mess around doing $squiggly crap everywhere, where you have to dynamically, I'm just going to pause this a second. You don't have to do $squigglies everywhere, just connect to your database. And then at runtime, if your production use a different string, you just use logical names for all your services, and Kubernetes wires it to the right thing. So you don't have to do lots of $squigglies or profiles or all sorts of weird dependency injection crap. You can just hard code URLs to all your services and use DNS, which is amazing. Right, so we've now done our canary build, so we've created a new version of the software, we've tagged everything in source code, we've pushed the tag to Git, we've created a new Docker image with that version name, so we've got a binary Docker image now. We've ran the integration test build, now we're doing a rolling upgrade in the staging environment. Can you just see that thing in the middle that says staging? And you see, you might not be able to tell, that's a blue little button that says 1. When things start up and they're not quite ready, they go blue, and then when it's ready, it goes green. Ready means it's ready to serve traffic. And Kubernetes lets you do something called a readiness probe that says, I've started a container, but I can tell you when it's ready. For example, can I get to 200 on the index of a web server? It can keep pinging the URL of the web server, and when you get 200 back, it's ready. You can define your own readiness check. We generate a Maven site, which is really lovely. Everybody loves a Maven site. So we generate one of those for every version, which is nice. So you get Java, Docker, dependencies, and all that kind of stuff. We also generate, we have metric dashboards for different kinds of applications. This one happens to be a camel application, so we have a custom dashboard that visualizes the camel throughput rates of the message flows. You can create like a custom dashboard for your Spring MVC app or your Node.js REST API or whatever. So different kinds of applications can have different kinds of dashboards that are linked to each other. Where have we got to? So we've gone to staging, we're deployed in staging. Now almost everything on this page is a link you can click on. So we can click on the pods or the containers. So we clicked on that. So now we're inside the staging environment now. We've looked in the staging environment. These are the running containers in the staging environment. So we can look in all of our environments, dev, test, stage, QA. And for each one of them, we can look at the logs of all the containers. We can open the shell in the container to see what's going on. We can scale containers up or down. We also have a deep visualization for Java stuff. So if you ever use JMX or Camel or ActiveMQ or any popular framework, we have a nice little WYSIWYG diagram that lets you visualize everything that's happening inside the JVM. So here we're showing the real-time visualization of message flows through a Camel JVM by looking inside a single JVM in this staging environment. The important thing to remember is if you're on this horizontal team in microservices, you want to be able to look in any environment and figure out what the hell is going on, right? So you want to be able to look in production containers, testing containers, staging containers, right? Different organizations might have different security rules, so you might not be able to do anything to production possibly, but at least you should be able to read what's going on and look at the rules. So here we're looking at the centralized logging of the new app we just ran, so that's all kind of cool. And I think in a minute we're going to do a code change. Let me just see how I'm doing for time. Oh, I should speed up. So I think what we're about to do is a code change. So we're about to go to the source code for the Node.js app, I think. Oh, we need to promote. Sorry. We're going to promote to production. We're going to proceed, and now that's going to do the deployment step to production. So we've done the system, we've done the build. We're not rebuilding again. We've got an immutable image. We've moved that image into testing, and it worked. We moved that image into staging, and it worked. And that image is then moved into production. So the same image and the same Kubernetes metadata has moved to all the environments. We've not been rebuilding anything, we've not been generating different apps. You maybe just missed that, but there's a little icon on the dashboard that lets you open. If something's a web service or a web app, we can test it directly in each environment with one click. So we just tested the application in staging. It's a really impressive application that says hello world. What we're going to do now is, I think we're going to, let's promote it to production. So we're going to promote it to production, and I think we're going to test it in production as well. So you see the little open icon to the right? Oh, so we're not going to do that. Let's look at the source code. A really awesome piece of JavaScript. I think it's one of the best I've ever written. We're going to edit it, and we're going to type a name of a city that's not quite that close, but in the same state. I think we're going to type, San Francisco. Okay, that's the same state. It's not that local, but it's close. So we've changed the string to hello San Francisco. Because what we've done there through the console is we've edited the source code, which has done a git commit and git push, which has then triggered the webhook to tell Jenkins to do another release. So that's going to kick off a new release. While that's happening, this is the team dashboard. So this is looking at all of the environments across the top and all of the microservices vertically. And for each microservice, we can see how many containers are running in each environment. We can look at the containers with one click. We can scale them up or down trivially with one click. And we can also see the version of the code that's running in each environment, and we can test them. So at a glance, we can see all of our microservices and what they're doing. We can now see a rolling upgrade happen. Here we're deploying the new version to the staging environment. So we have two containers running with different versions. And as soon as the new version is up and happy and we're ready with it and it's serving traffic successfully, the old version is going to shut down. So we're doing a rolling upgrade right now in the staging environment. If that all looks good, I think we're going to test it and then we're going to promote it. So just to kind of recap what we've just seen, there's lots of stuff here and you've probably been lost in all of this eye candy and whatnot. What we've done is, well, we did two demos in one. We did starting from scratch, creating a Kubernetes cluster and putting Fabricate on top, which is something you only do once. We've also shown you creating two microservices from scratch, a Java one and a Node.js one, and both of them went from development through testing, through staging to production with human approval, without writing a line of a Jenkins file, without hacking Groovy, without doing anything. And we're visualizing the pipelines, we're visualizing the build logs, and we're seeing what's running in every environment. So we can all just look at these screens and see exactly what's going on, right? There's consistency in all of this. It doesn't really matter what languages you use, what frameworks you use. You might use the latest, greatest Golang, cool Ninja stuff. You might use Haskell, or you might use Node.js or Spring Boot or whatever. It doesn't really matter. Everything works about the same. You can plug in any kind of build mechanism in any language. It's all based on Docker images, so it's all nice and simple. Here's a little example showing, I think we're comparing the memory usage across different containers. So we're looking at the staging environment, all the different microservices that we're running. So we're looking at what's the different memory footprint between the Node.js app and the Spring app, which is slightly embarrassing for us Java guys. Java's quite big, memory-wise. But it's easy to use though. Now we're going to do a quick check of some of the app dashboards. So every time we do a git commit, create a project, we do a deploy, we do an approve, we log events in Elasticsearch. So we can do all kinds of charting and dashboards to show how teams are working, how microservices are working. Are the builds taking too long in a certain microservice? We can look across teams, or we can look across microservices in a team to see relative time, how many commits do we do, how many builds do we do, how long do the approvals take, are the approvals taking too long, are the builds taking too long? And a bit like today's keynote, you need those metrics to find out where things are going wrong, where's your lead time going too long. These charts at the bottom, on the left one, that's the number of builds, so we can see which are the most active microservices in terms of builds. The middle one is all about log volume and errors versus warnings and stuff. So we can see we actually left debug logging on one of our microservices, which is causing huge amounts of logs, which is shown in this chart. And the other chart there is showing the relative approval time of different processes. This time we were approving fairly quickly, so everything looks kind of neat, but you might have one particular microservice that takes a long time to approve, which is a problem we need to optimize. Okay, that's a quick run through of the demo. The most important thing to remember is, once you've got this thing installed, which is really 2 commands, any team can just spin up a microservice, and your microservice immediately goes from development all the way through to production before you've written any code. So you know the pipeline's working, you know your environment's working, then you can just start iterating, and as you iterate, you have your logs, you have your metrics, you can see how everything's behaving, and it's easy to look across teams to find teams that might be having issues, that they can't figure out how to do an approval. They haven't done approval for 2 weeks, maybe there's an issue there and whatnot. So you can start sending, get some of the high-performing team to help the lower-performing teams to raise everyone up to awesomeness. So that's a very quick run-through of a demo. And I'm quite almost out of time. So I'm going to quickly do a couple more slides to tell you about some of the detail. Oh, I'm so out of time, it's so true. Right, if you want to try that demo right now on your laptop, download this binary. I'll share these slides after. Download this binary and type that command on your laptop. Go Fabricate start. That will run on your laptop a local Kubernetes cluster with Fabricate inside it. So that's all you need to do. You don't need to install Docker, you don't need to install VirtualBox or any of that stuff. Just type those 2 commands in and that will boot up a single node cluster on your laptop. You might need a bit of memory in your laptop, like 8 gig of RAM maybe or something, to run everything. There is a smaller version of that, which I'll show you in another slide, but it's a much smaller cut-down version of Fabricate where it's more just a development box only. We have Jenkins and Nexus and everything. But that's a really quick way of just getting started on your laptop without worrying about all this complexity and clouds and stuff. If you want to do a real cluster, you've got various different options for creating a cluster. You saw the Google Container Engine version, which is pretty simple. The next one down, I'll put these on Twitter and stuff too, but feel free to take snaps. There's a lovely website called stackpoint.io. If you want to use Amazon, or you want to use Azure, or you want to use DigitalOcean, or any of those kind of public clouds, it's got an amazingly simple web interface that is as simple as the Google one, where you just put in your credentials for, say, Amazon. A couple of clicks later, you have a Kubernetes cluster. And it's free, and it's using your Amazon account, or your Azure account, or your DigitalOcean account. So definitely highly recommend StackPoint. On the Fabricate website, they have long instructions on how to do all this with videos and stuff. But this is just a quick bunch of URLs for you. OpenShift and Kubernetes themselves have on-premise versions of this. If you've got a bunch of boxes or you've got a data center, you can install this stuff. And once you have any of those clusters running, you just go Fabricate, deploy, and you're in business. So that's how you run it yourself. If you're a Java guy, how many people do Java in this room? Okay, cool. How many people use Maven? Okay. Okay, yay. Go Maven. So people use Maven. We have a Maven plugin, a maven.fabricate.io. The first command you see there, the long one, if you have any Java project, ideally a Spring Boot one or a flat class path one or a fat jar one or Wi-Fi Swarm or Vertex, if you type that first command, that adds the Fabricate Maven plugin into your POM. If you type the second command, the Maven Fabricate cluster start, that does the same thing as the previous slide. That'll boot up a new Kubernetes cluster on your laptop and install the Fabricate console. This one only runs the Fabricate console, so it's much smaller, so it will run on a much tinier laptop. Then to test out your application in development mode, you just type Maven Fabricate run. That will then build a Docker image for your Java stuff. It will generate the Kubernetes manifest and deploy it into Kubernetes for you. So this is the kind of stuff you do before you commit. All the demo I just did was the post-commit, right? You do the commit, and then all this continuous deployment pipeline happens. This is the stuff you do for before deployment. If you want to run things locally on say, a local cluster on your machine or a cluster that you're sharing with some teammates, this is how you can just run stuff and see what happens, and then debug it and trace it and whatever. So that's local development. I mentioned before, these are the three big giants we stand on the shoulders of. Let me talk a little bit about how the architecture works. So we're absolutely using Jenkins pipelines for all of the CD pipeline stuff. It's just vanilla Jenkins, there's nothing kind of weird about it, it's just Jenkins. We're using Docker images for all of the tools. Now, one thing you've always been able to do with Jenkins is install tools, where you kind of say, install Maven 2.3 in the master, and then it kind of copies it onto slaves and all that kind of stuff. That's okay, but once you go Docker and you go Kubernetes, it's much cooler just to put all of your tools in Docker images, because then there's Docker images can be reused in any pipeline trivially. If you've got lots of Jenkins masters, you don't want to start going to all these Jenkins masters installing different versions of Maven. So you can just refer to the Docker image and version in your Jenkins file. So you can move to any version of Maven, any version of NPM. If you can find a Docker image with Maven in it of the right version, or NPM or whatever, you can just use it. So please use Docker images, and don't use the tools of Maven, the tools of Jenkins. We use Kubernetes as the orchestrator and environments mapped to Kubernetes namespaces. Often production, you might have multiple clusters in different regions that all federate together. But typically in development testing, you just got one cluster. Each team gets their own environment, so development, testing, production. However many environments you need, you can just spin up as many as you like. And each team gets to run their own tools. So one team might love Nexus, one team might love Artifactory, one team might use GitLab, one might use Gogs, and so on and so forth. You might use different versions of Jenkins, different plugins in Jenkins, and each team gets their own dashboard, either at the team level or at the microservice level. Almost done, almost done. So prefer Docker images to tools. What we've found is using Jenkins files for microservices is ideal, because each microservice then has its own pipeline in source code. Right? So you write your Jenkins file, you check it into the source code of your microservice, all of your build configuration is then in source control. So every time you change your pipeline, every time you change Maven versions or whatever, that goes in your continuous integration, continuous delivery pipeline. So everything's versioned and you can roll forward and roll back. One thing Kubernetes does is secrets. When you do a build and you want to do a release to, say, Nexus or Artifactory, or you might have a shared Docker registry or whatever, you often need secrets to be able to do a push in a Git repository or a Nexus or an Artifactory or a Docker registry. Kubernetes has a thing called secrets, where you can put all these secrets inside Kubernetes and then mount them into build pods. So rather than having to copy and paste secrets into, say, Jenkins config, you can put them all in secrets in Kubernetes and just map them into your builds, which makes things really simple. Having a Jenkins master per team helps each team go faster, because they don't have to talk to anybody to change versions. And as you saw before, we have a library of Jenkins files. So you don't have to write a Jenkins file, you just pick one from the library. Once you've picked one, you can edit it to your heart's content, but it saves you facing writer's dilemma of a blank page, and you have to think of groovy syntax and stuff. And Jenkins pipelines are awesome. I'm kind of over time, but I'll just sort of mention some of the other giants we support. We have a whole raft of different open source tools for ChatOps and chat integration, Chaos Monkey for random decaying pods to check that you have to survive failures, all the metric stuff we talked about, Jenkins, Hubber, Jables Forge, and so forth. There's the ChatOps example, Zipkin, we use Zipkins for tracing. Once you start having lots of microservices, it can be hard to know which microservice calls which other microservice and what links are. Zipkin is just one click to deploy, and you get lots of nice charts and graphs. If you need circuit breakers, Hystrix is the one you want, and we have a nice app called Hystrix Dashboard. Here's how you do system testing in Arcadian, in JUnit. I don't have time to talk about that. Here's the conclusions. So, Jenkins Pipeline is rock for continuous delivery. They are totally awesome. You should definitely use them. But everybody knows that in this room anyways. I don't need to tell you that. Kubernetes is an awesome platform for container-based development, microservices, and continuous delivery. I highly recommend you give it a go. It's the best open source project I've ever used in my life. It's amazing. I'm well gelled. I didn't make it myself. It's just a stunning piece of work. I can't talk highly enough of it. Please take Fabricate for a spin, see what you think. Fabricate just adds microservices to glue all this stuff together, right? It doesn't hide Jenkins, it doesn't hide Git or Docker or Kubernetes, it just helps blend them all together into even better awesomeness. If you need help, click on the community link. We've got GitHub issues, GitHub, Slack, IRC, Stack Overflow, an email group, or grab me on Twitter if you want to ask me any questions. I'm here the rest of the day and the evening. If you've got any more questions, come and grab me. I'm going to keep talking until people kick me out, basically. So, any questions? That's me. I'm done.